How do you tell somebody that you're going to be performing some activity on February 29th at 1 p.m. in 2024 in Amsterdam? You didn't know exactly when this event was going to take place until I told you in Amsterdam. Servers have to tell us when something's going to happen all the time, and that can be quite tricky. My name is Donnie Walls, and I will be telling you about working with dates and Codable in Swift. Now, if you're not yet subscribed to this channel, make sure you hit that subscribe button. If you like the video, make sure to hit the like. I don't have to tell you all of this, but I know that it drives engagement, so here I am telling you the obvious. In any event, working with dates and Codable in Swift. Dates are essential because, as I just told you in the intro for this video, if I'm just telling you that I'm going to do something on February 29th, 2024 at 1 p.m., you have no idea when exactly something will happen. You could assume that I live in Amsterdam, so therefore probably I mean Amsterdam time, but there's no way for you to be sure. And if a server is sending you this kind of information, it's kind of important that you understand how the server could send you this information and how you can transform that information into something that you can work with in Swift. So in this video, we're going to look at a couple different ways to work with dates. We're going to look at up and downsides, and we're going to start by looking at the default approach of how JSON, Codable, and Swift work together with dates. So everything I say in this video is going to be about decoding data, but it all applies to encoding equally, okay? But it's just decoding is by far the most common operation, so that's what I'll be talking about most. So if you ask a JSON decoder to work with a date, it's going to expect the JSON to contain the date information as a double. And that double should represent the number of seconds that have elapsed since January 1st, 2001. That's pretty non-standard because a lot of systems will actually take January 1st, 1970 as the starting point of computer time. And if you tell a computer that you're giving it a timestamp of X seconds, it's going to assume that it's X seconds since January 1st, 1970. But not JSON decoder. JSON decoder expects you to give it a number of seconds since January 1st, 2001. Now, if a server just sends you that, things can be a little bit weird because that timestamp is going to be in a number of seconds from whose time zone? Typically, it will be the server's time zone, right? And if you are in a different time zone than the server, then that number might not represent the date as you might expect, right? If the server is telling me this amount of seconds since January 1st, 2001, and that server is in New York, then the resulting time is going to be a lot different from what would happen if I did that here in Amsterdam. Okay, so this timestamp-based date stuff is not great. It's honestly kind of essential that I know which time zone at least this timestamp represents. And typically we use a convention that a server should always use UTC time for this kind of stuff. But if the server doesn't, it can be really tricky to figure out that it doesn't and to figure out what it does use. Consider the following JSON. For example, I have a JSON here and it has a couple of to-do items on it and all the dates are represented as doubles. If we want to decode this into Swift structs, we can use a JSON decoder. So here's what that looks like. We do let decoder equals JSON decoder, and we tell it to decode a list of to-do items. And this works fine. And because all of our dates are passed as timestamps since January 1st, 2001, this works exactly as expected in my time zone. Other time zones probably get bad results with the date where they're off by a couple of hours, where the couple of hours is the exact offset from my time zone. Now, that could be okay if we're wanting to represent everything as my local time, but we probably don't want to do that. And more importantly, we should consider what happens if our server uses the more standard reference date of 1970 instead of 2001. How can we deal with that? Let's look at that first, and then we can look at time zones. So if our server is sending us dates and number of seconds since January 1st, 1970, we can actually set a date decoding strategy on our JSON decoder. And we can tell it to use the number of seconds since 1970 instead of the standard, which is deferred to date. right? So the number of seconds since 1970 is more standard. Some servers use milliseconds since 1970, and we can also use that as a date decoding strategy. So that's all well and good. But again, time zones can wreak havoc here, and I keep hammering on about time zones because time zones are always going to be the thing that mess us up when we work with dates. That and leap years and leap seconds and everything else that's really hard about dates. But time zones are bad. They're good, but they're hard to deal with. Anyway, because time zones are hard to deal with, we have something like a standard that allows us to agree how we represent dates in code, or in text rather. So ISO 8601 is a standard that describes how we can represent a given date plus time zone as a string. Right? And we can represent only a date or only a time or all that stuff. There's various date formats that are allowed by ISO 8601, but for the purposes of this video, we're just going to look at the full-blown thing where it's date, time, and time zone. Here's what I would write if I wanted to represent February 15th, 2024 at 5 p.m. in my time zone in Amsterdam. Right? So you can see the year, the month, the day, followed by letter T, which indicates we're about to start our time. Then we have 17 for 5 p.m., 0, no minutes, 0, no seconds, and then plus 1, where 1 is the offset from UTC. And Amsterdam has an offset of 1 from UTC during winter. And this kind of stuff is particularly important when we talk about meeting times. If I were to start a live stream or launch some course or something at a given time on a given day, it would be important for everybody else in the world to know that it's not whatever time in their local time zone, but that that time is represented in my time zone so that the UI can actually show which time it would be in their local time zone. Right? It makes displaying localized dates and times a lot easier. And we can actually tell our JSON decoder to look at date strings and figure out which ISO 8601 compliant format is used. And we do that by setting the date decoding strategy to be ISO 8601. Really convenient, really great. All right, an example of a JSON file that follows the ISO 8601 standard is this. Right, you can see here that all of these strings that are used as dates have the format that we talked about earlier. And our decoding logic would look like this. As I mentioned, we set the date decoding strategy to be ISO 8601, and that's all we need to do. Right? This tells the JSON decoder that there's going to be a structure to the strings in our raw JSON, and it's going to figure out which format works. But what if we need more control? Because as good of a job as ISO 8601 does, sometimes there are date formats that should be compliant to ISO 8601, but for some reason JSON decoder isn't picking them up. Well, we could do one of two things. One is we could provide a custom date formatter, or we could even provide a closure to provide a lot of custom processing and a lot of custom logic. So sometimes we'll want to do this, and let's look at an example of using the custom formatter strategy first, so that we format it. Right, we see an example here where we make an instance of a date formatter, we assign a date format to it, we set the locale for this formatter, which is really important. Unless you have any specific needs, if you don't know which locale you should be using, you should always be setting it to EN/US POSIX. And also you can set the time zone for your date formatter. So that means if you are decoding your date and you're wanting to represent that date always in some given time zone, for example, the user's home country, regardless of their current location or something like that, then you could set the time zone to seconds from GMT. In this case, I used 0. And then we can use our formatter by passing .formatted, and then the formatter has the date decoding strategy. Relatively straightforward, really powerful if your server uses something that just doesn't fit what JSON decoder likes otherwise. A custom formatting strategy is quite complicated. We can use a closure to take full control of the decoding process for our dates, and here's what that looks like. Right, notice how we have this custom case with a closure that we pass, and that closure receives a decoder. From that decoder, we get a single value container, and then we get a date string out of that container. This is all complicated stuff, I mentioned that. And then we can create our own date formatter. In this case, I'm using an ISO 8601 date formatter just because this is an example, not the most useful one, but it does serve as a good example of how you could make a custom decoder. In my experience, if you're needing this, then probably you should have a good talk with your backend team because they are doing some really funky stuff, like mixing and matching date formats or whatever like that. So these are a couple of ways that you can use to work with dates in JSON. I would say the most common and best practice way to work with dates in JSON in Swift is to make sure that your dates are in the ISO 8601 standard, because that means that everybody can encode and decode them and everybody understands what's happening. If you're working with seconds from 1970, then that's also doable, but seconds from 2001, I'm not a fan of that because the only system I know of that uses that would be iOS, and specifically it would be the date initializer, because iOS also works with 1970 in some parts of the system. Anyway, that's not all relevant. The relevant thing for you to understand is that 2007 is pretty much non-standard, while 1970 is super standard, but it lacks all time zone information, so that makes it a little bit tedious to work with and quite problematic in some cases. Again, ISO 8601 is, in my opinion, the preferred way to do things. If you have a slightly different variation of 8601 or JSON decoder just doesn't get it, providing your custom formatter is fine too. Once you start reaching for a custom strategy, maybe you should have a conversation with your backend team because I don't think that that's the best idea. That's all for this video. Thank you so much for watching, and I'll see you in the next one.